Hi, I'm Crizzelle Gonong and I will be discussing the first come first serve algorithm of CPU scheduling. CPU scheduling is a process of determining which processes will own CPU for execution while another process is on hold. This aim is to make the system efficient, fast, and fair. Defining the first come first serve algorithm, it automatically executes queued requests and processes in order of their arrival. It is the easiest and simplest algorithm, and in this type of algorithm, it processes requests to get the CPU allocation first, and this managed with a FIFO queue or first in, first out. The characteristics of this algorithm is it supports non-preemptive and preemptive scheduling algorithm, and it executed on a first-come first-served basis. It is easy to implement and use, and this method is poor in performance and the general wait time is quite high. Example of this is a buying a movie ticket on a ticket counter. Here are some terminologies that we need to know. The arrival time. It is a time which the process arrives in the ready queue. The burst time is a time required by a process for CPU execution. The completion time is a time process completes its execution. And the turnaround time is the difference between completion time and arrival time. And the waiting time is the difference between around time and the burst time. And the knot chart is a project management tool that illustrates a project plan. Sa ating simulation, meron tayong processing from P0 to P3 at ang arrival time is 0, 2, 3, and 4 and ang burst time ay 7, 9, 6, and 8. Para makuha natin ang completion time, kailangan natin gamitin ang knot chart para ma-plot ang timeline at makuha ang completion time ng bawat processing. Ang arrival time ng P0 ay 0 and ang burst time is 7 at ang P1 naman, ang arrival time is 2 and ang burst time is 9. So, i-add natin yung 7 sa 9. So, it equals to 16. And ganun din sa mga susunod na processing. Ang P2 is, ang arrival time is 3 and ang burst time is 6. So, i-add natin ang 16 and 6 at magiging 22 ito. And ang last, P3, i-add natin yung 22 sa 8 sa burst time ng P3. It equals to 30. So, ito na ang magiging completion time natin. Para makuha ang turnaround time, ang formula is completion time minus arrival time. So, ito and ito. 7 minus 0 is 7. 16 minus 2 is 14. 22 minus 3 is 19. And 30 minus 4 is 26. Ang waiting time naman is difference between turnaround time, and burst time. So, 7 minus 7, 7 minus 7 is 0, 14 minus 9 is 5, 19 minus 6 is 13, and 26 minus 8 is 18. Para naman makuha natin yung average ng turnaround and waiting time, kailangan nating i-sum, total, yung turnaround time and divided by the number of processing. So, sa ating turnaround time is, ang total ay 66. And ang average is divided by 4. So, ang average na is 16.6 millisecond. Sa ating waiting time naman is nagtutotal ng 36 para makuha yung average divided by the number of processing divided by 4. So, ang ating waiting time is 9 millisecond.
Shortest remaining time first, CPU scheduling algorithm, is a scheduling method that is a preemptive version of shortest job next scheduling. The process with the smallest amount of time remaining until completion is selected to execute. Since the currently executing process is the one with the shortest amount of time remaining by definition, and since that the time should only reduce as execution progress, the process will either run until it completes or get preempted if a new process is added that requires a smaller amount of time. P0 came into the queue at 0 time and requires 7 milliseconds to complete the process. At time 2, P1 came into the queue and the CPU will preempt P0 and start processing P1 because P0 requires 5 more milliseconds while P1 requires 4 more milliseconds only. At time 4, P2 came into the queue. The CPU will preempt P1 and start processing P2 because P2 requires only 1 millisecond while P2 requires 2 milliseconds. Time 5, P3 came into the queue that requires 4 milliseconds and P2 is completely processed because it only requires 1 millisecond. P1 requires the least millisecond so it will start processing for 2 milliseconds. At time 7, P1 is completely processed. P3 requires only 4 milliseconds so it will start processing for 4 seconds. Lastly, at time 11, P3 is completely processed. It will now process P0 for 5 milliseconds. To get the turnaround time, we need to subtract CT to AT, and to get the waiting time, we need to subtract TAT to BT. To find the average of TAT, we need to divide the sum of TAT to the number of process. So 28 divided 4 is 7. The answer is 7 milliseconds. Same goes with the average of WT. 12 divided 4 is 3, so the answer is 3 milliseconds.
Good day, my name is Joshua Panambitan from BSIT-21 and my topic is about round-robin algorithm, CPU scheduling. First, what is round-robin algorithm? It is one of the preemptive algorithms employed by process and network schedulers in computing. As the term is generally used, time slices are assigned to each process in equal portions and in circular order, handling all processes without priority. Round-robin scheduling is simple, easy to implement, and starvation-free. Next, time quantum. A time quantum, or TQ, is the amount of time share give to each process, interrupting the job if it is not completed by then. Next, request queue. A request queue is the order by which processes arrive and are handled. So for the next slide, I have an example. So I have 5 processes: P1, P2, P3, P4, and P5. And for the arrival time, for P1 is 0, for P2 is 1, for P3 is 3, for P4 is 5, and for P5 is 6. So, the burst time for each processes are 5, 3, 6, 1, 4. For this example, our time quantum or TQ is equal to 3. So, first, the P1. The arrival time is 0. So, P1 is the first. The next, iaano na natin yon yung magkakaroon na tayo ng quantum na 3. So, 3, 5 minus 2, 5 minus 3 is magiging 2 na siya. So, next Q is 3, P2 and P3 dahil sa arrival time ng P2 at saka P3 is 1 second tsaka 3 seconds. So, pumasok na silang dalawa. Then next, P1 ulit. So, bumalik ulit sa P1 kasi di pa naman papasok yung P4 kasi sa 5 second pa siya papasok. So, bumalik sa P1. Ay, umangat yung P1. Next. So, the next Q is the P2. So, ang P2 is equal to 3. Ang time quantum natin is 3. So, ang P2 natin is completed na agad siya by 6 seconds. So, next. Dahil nag 6 second na tayo, so, ang arrival time ng P4 and 5 is pumasok na. So, ang Q na natin ngayon is P3, P1, P4, and P5. So, next. Sa P3, ang next Q natin. So, 3 ang time quantum natin. So, 6 minus 3 is equal to 3. So, may burst time pa yung P3 natin ng 3. So, mag-a-add ulit tayo ng Q for P3 sa dulo. Next. Ang next Q natin is P1. So, ang P1 natin, ang natira na lang is 2 seconds. So, 2 lang yung ilalagay natin doon sa may natin. So, ang P1 natin is completed by 11 seconds. So, next Q tayo is the P4. P4 is completed kasi nga 1 second na lang natira. So, ang completed siya by 12 seconds. The next Q is the P5. Ang P5 natin is 4 pa. So, 4 minus 3, may matitira pang isa. So, mag-add ulit tayo ng Q sa dulo ng P5. The next is, ang Q natin is the P3. So, 3 na lang yung natitira sa P3. So, 3 minus 3 is equal to 0. So, completed na yung P3 natin by 18 seconds. Next is the P5 na may natitirang isa na lang. So, by 19 seconds, na-complete natin yung P5 at saka lahat ng processes. So, next is, i-compute natin yung average turnaround time at saka average ng waiting time. So, paano mo siya kino-compute? First is, kukunin mo natin yung completion time. So, makikita natin dito na ang P1 is natapos ng 11 seconds. So, ang P2 naman is 6 seconds. Ito. So, the next is the P3 is natapos siya ng 18 seconds. For the P4, natapos naman siya ng 12 seconds. For P5, siya yung pinakalas na natapos, so 19 seconds. So next, paano natin ma-compute yung turnaround time? Ang sabi dito is complete time minus arrival time. So, ang turnaround time ng bawat isang processes natin is for P1 is 11. So, 11 minus 0 is 11. 6 minus 1 is 5. 18 minus 3 is 15. 12 minus 5 is 7. 19 minus 6 is 13. Next. Para naman makompute natin yung waiting time, ang computation natin is turnaround time minus burst time. So, 11 minus 5 is 6. 5 minus 3 is 2. 15 minus 6 is 9. 7 minus 1 is 6. 13 minus 4 is 9. So, ang hanapin ngayon natin is ang average ng turnaround time at saka average ng waiting time. So, first, kukunin muna natin yung total ng turnaround time at ng waiting time. So, ang total ng turnaround time is 51. 11 plus 5 plus 15 plus 7 plus 13 is equal to 51. Ang waiting time naman natin is 32. So, 6 plus 2 plus 9 plus 6 plus 9 is equal to 32. So, next. Kukunin natin ngayon yung average ng turnaround time and the waiting time. First is the turnaround time. So, para ma-compute natin siya is yung total ng turnaround time divided by the total of processes natin. Ilan ba? 5. So, 51 divided by 5 is equal to 10.2. While yung waiting time natin is 32, yung total ng waiting time divided by the total process or number of process is equal to 5. So, 32 divided by 5 is equal to 6.4 seconds. So, ang average turnaround time natin is 10.2 seconds while our average for waiting time is 6.4 seconds. So, yun lamang po and thank you very much for listening and watching.
Good day everyone, my name is Morante Andrei from IT-21 and my report is about priority-based CPU scheduling algorithms. First, what is priority-based CPU scheduling algorithm? Priority scheduling is a non-preemptive algorithm, meaning the CPU takes time to take the resource, and one of the most common scheduling algorithms in batch systems. Each process is assigned a priority. Process with highest priority is to be executed first and so on, and that is why it's called priority based. Processes with the same priority are executed on first come first serve basis. The process is repeated while all processes get executed. How it is to be executed or how it is to be implemented. First, input the processes with their arrival time, burst time, and priority. Second, first process will have the lowest arrival time. If two or more processes will have the lowest arrival time, then whoever has higher priority will schedule first. Third, now further process will be scheduling according to the arrival time and the priority of the process. Here we are assuming that the lower of the priority number having the higher priority. If two process priority are in the same sort according to the process number. Note, in the question, they will clearly mention which number will have the higher priority and which will have the lower priority. Once all the processes have been arrived, we can schedule them based on their priority. One, the process arrival time, burst time, priority. This is another example Gantt chart of course, and this is how it works. It input process the input order, arrival time, burst time, priority, and then the output, the process number, priority time, burst time, complete time, turnaround time, and waiting time. The average waiting time is 5.6 seconds. Average turnaround time is 8.8. Also, I want to add in the information, the CPU based priority is one of the common algorithms used in CPU scheduling. That's all. Thank you.
Hi guys, I'm Jose Maria Vera from the BSIT-21 and now I will discuss the multi-level feedback queue scheduling. In a multi-level queue scheduling algorithm, processes are permanently assigned to a queue on entry to the system. Processes do not move between queues. This setup has the advantage of low scheduling overhead, but the disadvantage of being inflexible. In general, a multi-level feedback queue scheduler is defined by the following parameters. First one is the number of queues. The next one is the scheduling algorithm for each queue, the method used to determine when to upgrade a process to a higher priority queue, the method used to determine when to demote a process to a lower priority queue, and lastly, the method used to determine which queue a process will enter when the process needs service. The definition of a multi-level feedback queue scheduler makes it the most general CPU scheduling algorithm. It can be configured to match a specific system under design. Unfortunately, it also requires some means of selecting values for the parameters to define the best scheduler. Although a multi-level feedback loop is the most general scheme, it is also the most complex. And now I will explain how multi-level feedback loop scheduling works. First of all, suppose that queues 1 and 2 follow round robin with the quantum 8 and 16 respectively, and Q3 follows FCFS. One of the implementation of multi-level feedback queue scheduling is as follows. 1. If any process starts executing, then firstly it enters Q1. In Q1, the process executes for 8 units, and if it completes in these 8 units, or it gives CPU or for I/O operation in these 8 units, then the priority of this process does not change. And if for some reason it again comes in the ready queue, then it again started, it executes in the Q1. If a process that is in Q1 does not complete in 8 units, then its priority gets reduced and it gets shifted to queue number 2. Above points 2 and 3 are also true for processes in Q2, but the time quantum is 16 units. Generally, if any process does not complete in a given time quantum, then it gets shifted to the lower priority queue. After that, in the last queue, all processes are scheduled in an FCFS manner. It is important to note that a process that is in a lower priority queue can only execute when the higher priority queues are empty. Any running process in the lower priority queue can be interrupted by a process arriving in a higher priority queue. Also, this implementation may differ. For the example in which the last queue will follow round-robin schedule. And that's all. Thank you.